So for number 22, we want to determine whether this geometric series is convergent or divergent. So a geometric series is convergent if the absolute value of the ratio, so the thing that's being raised to the power, right, is less than 1. The reason is if I take a number and I raise it to a very large power, say I take 1/2 and I raise it to 1,000,000, that's going to go to 0. Whereas if I take 1.01 and I raise it to 1,000,000, that's going to get bigger, right? And I need these terms to go to 0 because as I keep adding them, since this is an infinite sum, the only way that my sum is going to stay fixed is if I'm essentially just adding 0. So the ratio definitely needs to be less than 1. So now let's take number 22. Let's write it out. So before we can even look at what the ratio is, what we need to do here is we need to adjust the index because the first term of the geometric series is just a. And maybe I'm going to put this as ar to the power of 0. This is because it's indexed at 0, right? And you can see here that in this one, it's indexed at 1. So what we have to do is we have to adjust it so that the first term that it's going to be evaluating is actually the ratio to the power of 0. So you can see here that for the bottom term, we have -9 and -1. If I plug in the first index, it's actually going to be evaluating -9 to the 1 minus 1, so to the power of 0, which is correct. It's what we want, right? So we can see here that my index actually needs to be n minus 1 instead of n, because if I plug in 1, it's going to be evaluating the second, so the second indexed and not the first. So what I'm going to do here is I'm going to take this 10 to the power of n, and I'm going to multiply it and divide it by, I'm going to do it multiply and divide it by 10. So the reason that I'm going to do this is because this 10 that's on the denominator, so, well, if I multiply and divide it by 10, I'm just multiplying by 1, right? It's not changing anything. Now, this 10 that's in the denominator, this is the same thing as going 10 to the power of n times 10 times 10 to the minus 1, right? It's in the denominator. So instead, what I'm going to do here is I'm going to rewrite this as, I'm going to put this one here in front, so 10 times 10n times 10 to the minus 1, and now I'm just going to join these two by summing up their exponents. So that's going to be 10 times 10 to the n minus 1, because whenever we multiply, we just sum up the exponents. So once I've done this, I can see that if I plug in now 1 in the exponent, it's going to give me 1 minus 1, so 10 to the power of 0, which is what I want. And I haven't changed the meaning at all, right? Because all I did here was I multiplied by 10 over 10, which is multiplying by 1. So this is the same thing as going from 1 to infinity. That's going to be 10 times, that's going to be 10 to the n minus 1 all over minus 9 to the n minus 1. And which is the same thing as, now I'm just going to join these into a single ratio, 10 times 10 over minus 9 to the n minus 1. All right, so once we've done this, it's indexed correctly, and we can see here that the value of a, right, this thing that is the constant that's being multiplied, the value of a, maybe I'm going to highlight it like this, is 10, and the value of the ratio, the thing that's being raised to a power, is minus 10 over 9. So what we have here is that the absolute value of 10 over minus 9, which is the ratio, is definitely greater than 1. So that means that whenever you raise it to a very large number, it's not going to go to 0, and therefore it diverges. And so that is it for problem 22.